There's a very well understood series of transitions from microscopic foam cells in the top box through growing plaques, which are essentially engaged in a wound healing response with inflammatory processes that are exquisitely sensitive to diet and the physiology of the individual and the genetics. And almost everybody after the age of 40 has some level of plaques and beginning of calcification in one or more of their arterial beds. Luigi, do you agree with that? Yes. Okay. So we're all somewhere on one of these curves. So here are the cellular and molecular players at work in these wounding processes that are forming insidiously and very slowly in our major arteries with entrapment of blood lipids and recruitment of inflammatory cells. Now I want to bring home firmly for you how real the term inflammation is applied to atheromas. This is thermography of the arterial surface of a rabbit model of coronary plaques. Top panel before cholesterol feeding. No, this is abdominal aorta. Middle panel, the surface temperature of a plaque which grew within 3 months, and it's 1 degree centigrade hotter than the rest of the tissue. And then here it is, it cools off when the plaque regresses after the cholesterol feeding. So vascular disease is driven by inflammatory processes that throw off heat from exothermic reactions of locally generated free radicals. Do you agree? No. Okay. Yes?
Why was there a rabbit used in the experiment?
Because they get atherosclerosis with a simple dietary manipulation in a matter of weeks.
But cholesterol is not part of the normal wild rabbit's diet.
That's irrelevant. It's an animal model.
Okay.
So now I'd like to use some of the conventional blood pressure indicators and vascular indicators with age and map into this the values that have been published by the Fontana and Holosy papers. And here is systolic blood pressure increase with age from several different reference studies. And I've put onto this the control values from the Chronos study 2004 and the diet restriction group. So that looks pretty good. So there's no question that energy restriction lowers blood pressure. That's a powerful general response in all mammals. Yes?
Sorry, the Chronos study, you mean the Washington University of St. Louis?
Yeah, this is the Chronos Society, the Crohn Society, right?
Oh, Crohn, yes.
This is mislabeled. I'm sorry. I should have it's Crohn.
We're just the CR Society.
Yeah. But how do you refer in the 2004 PNAS paper?
Probably, I mean, it was wrong because it's calorie restriction with optimal nutrition, so it's a Crohn's. But
that's what I wrote
yes,
from the paper.
But the name is CR Society. It's just.
I thought you meant Chronos Laboratories, Dr. Ebert's operation.
Okay, I was just copying it from the paper, and
No, but you're right.
So is this should I modify this in future?
The society is called Calorie Restriction Society, but they also call themselves Crohn's, calorie restriction with optimal nutrition.
Yes. So is it just to avoid confusion? Will I Will I impinge on your sensibilities if I use Chronos on this slide, or should I change?
Yeah, the confusion is that it's Chronos is the Chronos Clinic, which is quite separate.
Okay, so I'll let Luigi email me how I should modify this. I was just being faithful to what I saw on the printed page in the National Academy of Sciences.
So what are we seeing here in the black and then with the green?
Okay, the green is the diet-restricted group.
Okay.
Yeah, and it just points out that for the age, the systolic pressure is about 20 millimeters lower than the normative for that age on the national studies, as well as the control group that was used in the Washington University study. So here is really serious stuff. These are the risks of fold risks of coronary artery disease mortality and stroke mortality for 5 decades versus systolic pressure. So the vertical axis is exponential. So no matter where you are in your blood pressure, your risk of a vascular event increases exponentially with age. But the position that you are in the systolic pressure makes a huge difference. So here is the same group, which had an average of 100. So you can see it's quite well positioned. Inflammation are a very good candidate in this, and the reduction of these conditions would tend to favor slower development of the chronic conditions of old age. So here's a glimpse of some of the data that can be brought onto this discussion. Here's a Norwegian historical population, infant mortality for males and females on the horizontal axis versus in those same populations, deaths from vascular disease at age 50 to 70. So there's, this is just one of a number of studies showing that infant mortality can be used as a surrogate variable to predict mortality later in life. So how would this possibly work? Well, our argument is that survivors of a high mortality regime as infants would carry infections and inflammations to a greater extent than those born into low mortality regimes. And